Alright, let me show you a quick demo of Pre6 PPAP. I have a drawing here. It's an enclosure which has about 100 of dimensions. If I have to make a PFMEA and control plan for this, it would take minimum of a day or two. Using Pre6 PPAP AI software, we can do this in less than 10 minutes. Let me show you how. This is a typical process flow diagram that a process engineering team would be generating for any part that is to be manufactured. It's a recipe which has all the list of sequence of operations using which that part can be manufactured. Right from the start of raw material being received till the dispatch, it has a lot of information sometimes around the machine details and which part is being discussed, what is the revision name, and everything. Using Pre6 PPAP, we can develop the PFMEA and control plan for this in less than 10 minutes. Let's see the magic. Sign in, create PPAP, upload the PFD. As long as an engineer can understand the process flow diagram, our AI can also understand it. You can upload the PDF or a spreadsheet. The AI will go through the document, it will see what part is being discussed, what is the part name, part number, revision number, customer name, the sequence of operations, all the operations name, any machine information for any of that, and then it will summarize its understanding in this beautiful layout. You can see right from the raw material being received till the dispatch, everything has been understood, the sequence have been correctly noted, along with any machine information that was present has been read and listed in front of us. What are these selections? Let's look at anodization and drilling. Drilling will affect certain dimension in your engineering drawing. For example, couple of holes. Anodizing is a process which will be applied on the entire body. We select those operations here which will affect any dimensions. For example, drilling. AI has already selected some of it, but we can always override and change. This looks good to me. I'll confirm and continue. In the next screen, we have to provide the engineering drawing. Previously, we provide the recipe. Now we provide the engineering drawing. Two engineering drawing I have. I'll select that. What we have to do here is guide AI and make it understand that this operation casting will affect all the dimensions in the first drawing. The milling, bore milling, different bore milling setups, and drilling are the operation that will affect the second drawing. But just by clicking, I'm able to declare my mapping to the AI. Next, the first file is now being analyzed by the AI. We have a world-class capability that understands an engineering drawing and balloons it just as a world-class engineer would be doing, just that it's much faster. So AI has been able to understand all of this engineering drawing and parse all of the values and balloon it as well for you. If you are satisfied with the ballooning, you can download the inspection sheet and the balloon drawing. We have added this option for operation picking. So this allows you to pick an operation, say casting, and select any dimension that is going to be achieved by that operation. Here, since it's a one operation, one file mapping, the tool has automatically mapped every dimension to this operation, which reflects next to that dimension as well. I'll go to second page. Here I can see everything is auto selected already. This looks good to me. I can press escape and exit the operation picker mode. I'll go to the corner, save and continue. Now the second file is being analyzed by the AI, and within few seconds it will balloon the entire drawing. It will read and understand all its dimensions. Remember, there were four different operations. These are all the four operations. Now let's go with one by one. Drilling. Closely look at this engineering drawing. These are the two holes and these are the dimensions of those. So drilling will be affecting all these dimensions. So I will be dragging and selecting like this, and that's it. It's enough to let AI know that this operation will be affecting these dimensions. So I have to pick the right failure mode. As simple as that. Now I'll quickly do the same for all the operations. I have milling. In my setup, I'm going to do milling operation in all of these dimensions, including this one, and one more dimension here. That's my milling setup. I have a bore milling one setup, these dimensions. Just drag and get selected. Now I have a bore milling 2 where I will be achieving these dimensions. That's it. Once you are ready, you can save and finish. And within a matter of few seconds, your entire PFMEA of 1000 rows is generated. Not only this, you can even export this in your own custom template, or we can provide you a template. And when you click on export, within a matter of few seconds, AI will write all those 1000 rows in your defined PFMEA export template. Look at this. It's an AIG ready document to be shared. Let's see. Milling, balloon number 83, linear dimension. It has two failure modes, oversize and undersize. And both the cause, effect, severity value, occurrence value, detection value, and RPN are auto calculated. Columns, we are covering the operations, the requirements, be it product requirements, process requirements, failure mode, effect, the severity, the cause, prevention control, detection control, occurrence, detection, and RPN, which is the multiple of severity, occurrence, and detection, all auto calculated. This itself takes a lot of time to compute, but it was done within less than 5 minutes. All right, once you have it, you might be thinking in your company there are very different operations, there are very different failure modes, effect and cause. How would AI get to know about your failure modes for your operations? I'll take an analogy here. Let's say tomorrow a new person joins your team, and it's his or her responsibility is to generate PFME and control plan. How will you bring that person up to the speed? You will share some of your recent 5 to 10 PFMEA and control plan documents with them and ask them to go through it. Learn the kind of operations we have, the kind of failure modes we have for certain features that we achieve through that operations, the severity value, how many times it has happened, that is the occurrence value, all of that, and refer that or use that going forward for developing any PFMEA or control plan. We go with the same analogy. We have a option here called FMEA library and control plan library. What you're looking at is a snapshot of an understanding AI has generated when we imported some of this historical PFMEA data. When we upload that, AI creates this understanding on its own, which by the way, you can edit any point in time. If you feel the severity is now modified, you can modify all of it, and AI will use this latest data to write your PFMEA. All right, let's look at it like this. This is exactly the representation of its understanding. AI understands that milling has all of these features. Each of these features have these many failure modes, and each of these failure modes have these values. And anytime you click, you can edit whatever you want to edit in this, and AI will respect that. It's so simple to visualize. Now, going back, once you're done with PFMEA, which by the way, you can also modify the part specific PFMEA. For example, here if I modify this from 4 to 3, this will not update your library. It will only affect your PPAP document that is being discussed. So that degree of freedom is with you. You are always in control. You can modify anything that is present here. Once you are satisfied with this, you can save and continue. And within a matter of few seconds, your entire control plan is also ready. What AI did is it was able to figure out most of this data from your historical data, and then it is reasoning all the blank or unfilled empty cells again, and it is filling it cleverly. Look at it. And within a matter of few seconds, your entire control plan ready to share is generated. It has process or product characteristics or process characteristics, the specification, the measurement, sample size and frequency that has been referred from your historical data, the control methods, prevention and detection control, along with reaction plan. Now you can export this in an AI AG template or your own template. The moment you click on export, within a matter of few seconds, it is exported. Look at this document. It is filled with the part information, all the columns, including responsibility, the process characteristics, product characteristics, the specifications, measuring. Cells are also merged wherever the data was same. If you look, it's beautifully merged for all the common data. And that's it. Thank you.